and then also something that's called an indefinite integral. An integral is another of the main components of calculus. All that we've really focused on so far have been derivatives and differentials, which are very closely tied to each other. This is actually going in the reverse order of the question. Just kind of to show you what's going to happen, they're going to tell you what the derivative is. You have to say what was the original problem that gave me that derivative. We've always had the original problem writing the derivative. Now we're reversing that order in our question. Okay, so you don't need to write this first slide down inverse. What does it mean if I have an inverse operation in math? So don't think inverse like reciprocal or anything like that. What does inverse mean? The opposite. So inverse operations, they undo each other like multiplication and division on our question. What we're going to see in our lesson today, to differentiate a function, you write the derivative. That's like what you just did on the quiz for me in the first 3 questions. I gave you a problem, you wrote the derivative. What we're doing, and this is where I would like you to just write something down here, is called antidifferentiation. That's a giant word there. So antidifferentiation is the opposite or the inverse of differentiation in the question. Again, what the goal is, you're trying to go back to the original problem. You have the derivative, or you have the differential. You need to identify what original problem gave you that answer. Now, with the 2 things that show up in lesson 32 here about this antiderivative, and then also the indefinite integral that we'll get to tomorrow, these 2 are almost identical to each other. There's going to be one difference, and we'll see that in our lesson for tomorrow. With antidifferentiation, it cannot give you a unique answer. What that tells me, each of you 3 could give me a different answer, and they all would be correct in order for an antidifferentiation question. On the indefinite integral question, there's only one answer. There is a unique answer. That's what I mean by a unique answer, just one individual answer. An antiderivative, there's many answers that you could give, and they're all correct in our question. What we're going to notice here, so it's got a bunch of answers, multiple of answers. They're going to differ by a constant. And what's that word mean in math that we have a constant? It's just a number. Okay, so I'm going to show you 3 questions. We're going to identify the derivative. So you can see what I'm attempting to explain here today. And then the goal was eventually to go backwards. They give me the derivative. We have to come up with the original question in our problem. All right, so if I gave you this function, if I said that f of x was x squared, what is the derivative of x squared? It's 2x. Okay, so at f prime, that was our derivative notation, the derivative is 2x. What is my function? So I'm calling it a different function, so g of x is x squared plus 42. What's the derivative of x squared plus 42? It's 2x. I got the exact same derivative, even though I had a different function. If I give you this question, that h of x was x squared minus 165, what is the derivative of that question? It's 2x. Well, in our questions today, they're going to say the derivative is 2x. You have to give the original problem. Well, which one of these am I supposed to get? The x squared plus 42, the x squared minus 165? It doesn't matter. They all work in the question. I can say x squared plus a million. I can say x squared minus 5 trillion. Notice the only thing that's different about these is a constant. The the number that you have at the end of your question. Okay, you guys see what I'm trying to show you up there in the problem. So again, our goal for this antiderivative, we're going to start here. We have to go back to the original function. Well, any of those answers would be acceptable answers, so there's not a unique answer that we have in our question. To wrap up for this morning, so we just saw that 2x has many antiderivatives. The word antiderivative, that's the original problem. You're going backwards through the derivative formula. Instead of dropping the exponent, it's like you're putting it back in the question. So this 2 would have moved back up here in the question, but there could be anything back here for a constant, because a constant would just go away in the question. So do not write down the second bullet. Josiah, if you'll just read this for me.
No single function is the antiderivative of 2x because there are infinitely many functions whose derivatives are 2x.
Okay, so what does that mean? There's infinitely many functions. As long as it says x squared originally, you can put any constant behind it. You can't have any other variable there, but you could put any other constant behind x squared, and you're going to end up with the exact same derivative. That's why the antiderivative has many answers on our question. Let's see if we can do one of these examples together. So let's write down the function and actually, go ahead and do it. So f of x is 3x squared. My job, I'm going to see if I can write a function that's an antiderivative of f. Okay, so what this kind of notation means here. The derivative answer, that's why I was going to change it for just a second. The derivative answer is 3x squared. What original function, so it's calling it capital F for the original function, what original function would lead me to a derivative of 3x squared? Any thoughts on that? Yes, ma'am?
X cubed plus 71.
X cubed, and what did you say behind that?
Plus 71.
Plus 71. Okay, so for the x cubed, you would have dropped the 3 down to the front. There it is. You would have subtracted 1 from the exponent. There's the 2. And then the derivative of a constant would have disappeared. Is this the only answer that Alyssa could have given me? No. What would be another answer, Josiah?
Just x cubed.
You could have just said x cubed. Amelia, was that the only answer you could have said? No. Can you give me another answer?
X cubed minus 10.
X cubed, you say minus 10? Okay, that would have been another answer on our question. So what's interesting about an antiderivative going backwards, there's many answers that you could give me. So on a quiz, on a test, if I say find an antiderivative, you could have said any of those 3 answers and they all would have been correct. Tomorrow, when we look at something that's called an indefinite integral, it's the same idea as going backwards to the original problem, but there's only one answer that we can give, not multiple answers that we're going to give. There's a symbol that we're going to put in the question, and it's going to contain all of the constants that you could have put back there, and now I only have one answer in our question. All right, you guys understand what we're looking at for this idea of antiderivative? All right, so we'll continue that tomorrow, and hopefully we'll be able to